Okay, so let's see if we can come to some kind of understanding about the ratio test and why it works. First of all, we start off with an infinite series. And we think about the ratio of terms here. This is the n plus first term over the nth term. And we take the limit of that ratio. And suppose it equals some number, L. Well, if L is less than 1, we're going to conclude that the series converges. If it's greater than 1, we're going to say it diverges. And if it's equal to 1, we say that the test is inconclusive. So we want to understand, well, why does this work? To do that, let's just see if we can recall what it means when we talk about the limit of a sequence. When we talk about the limit of a sequence equaling something, like in this case L, so we're saying the limit of the sequence is L. Well, what we're talking about is if you go out far enough, in other words, if you go out far enough, if you let n be large enough, any epsilon neighborhood you choose about L will contain all the values of your sequence. So for example, let's suppose we're talking about this sequence, the ratio, the ratio of the successive terms, like a sub j plus 1 over a sub j. And here we calculate that ratio. Here's a sub j plus 2 over its preceding term. We get over here to a sub capital N plus 1 over a sub capital N. Now, what we're saying is no matter how closely, how small of a neighborhood I pick around the L, there's going to come a point, there's going to come a place where if I go beyond that, if I have n values beyond that, all the ratio values, all the values of the sequence, the sequence ratios, is going to be within that neighborhood. So see, I could compute some more values there, but let's just look at, let's call this n. This number right here, we'll call this is big N. And up here, I'm going to call this r. Now notice that r is less than 1. But what I'm going to say is, I'm going to say, okay, because that limit exists, it's L, I'm going to say that all the values of these ratios, a sub n plus 1 over a sub n, all the values of these ratios, all the values of this sequence is going to be less than r from now on, from this point on. Now, let's see what this means. Now notice that r is less than 1, and this is important in our ratio test because we were concerned, the issue was, is L less than 1, is it greater than 1, or is it equal to 1? So in this case, you can see it's less than 1. Now, from this, clearly, a sub n plus 1 over a sub n is less than r. I mean, you can see that from the picture. And that means that a sub n plus 1 is less than a sub n r, just by a little algebra. Now, you can argue, you can continue arguing and look at, well, a sub n plus 2 over a sub n plus 1. That would also be less than r, which algebra gives us this. And now realize that a sub n plus 1 is less than a sub n r. What if I multiply both sides by r? You could see algebraically that we could have this, right? And likewise, if we expand on with the same reasoning, we would have a sub n plus 3, and you get this relationship here. Okay, so let me summarize. Here's what we have. We have a sub n plus 1 is less than a sub n r. Okay, a sub n plus 2 less than a sub n r squared, and so forth. We have these values. Now notice that this looks a lot like a geometric sequence. And it is, or it's terms of a geometric sequence. This one right here. Notice, it's this. I mean, these are 4 terms of that sequence. But and this is a convergent geometric sequence because r is less than 1. So we know this sequence converges. Now, this is our original sequence. The one that, our original series, I should say. This is a geometric series, I should say. This is our original series. And you'll notice that, of course, I'm starting at n plus 1, big N plus 1, but notice that a sub big N r to the k is going to be greater than a sub big N plus k for all k greater than or equal to 1. Okay? In other words, this series here has terms that are less than this series. Well, then that means that this series converges by the direct comparison. So this illustrates why the ratio test works. Basically, if that ratio, a sub n plus 1 over a sub n, is less than 1, we're saying that our series behaves a lot like a geometric series if you go out far enough. Therefore, if the geometric series converges with a ratio less than 1, so does our series.